Dear students, today I am posting my next video on analog electronic circuits in which I am going to discuss inverting amplifier and non-inverting amplifier using operational amplifiers, using op amps. Okay, so let's start with the topic. So the heading will be inverting amplifier and non-inverting amplifier using op amp 741. Now here in this presentation, we will have the contains as a definition of inverting amplifier, circuit diagram of inverting amplifier, a definition of non-inverting amplifier, circuit diagram of non-inverting amplifier, and then a conclusion in the end. So let's start with the definition of inverting amplifier. It is a type of op amp that is designed to generate a signal at the output which is 180-degree out of phase. This is important. It is 180-degree out of phase at the output with respect to the applied input, and it is known as an inverting amplifier. This implies that if the phase of the applied input is positive, then the amplified signal will be in a negative phase at the output. In a similar way, for a signal with a negative phase, the phase of the output will be positive. Okay, so if you see the circuit here, you can understand. Now, this is your inverting amplifier circuit. Now, we are calling it as inverting amplifier because the input we are going to give to the inverting terminal of the op amp. So here you can see this is the point where we are going to give the input. So here you are going to give the input. Say this is your input. Okay. So this is your input which you are going to give between this point and ground. This is your ground. Okay. That means the input is applied to the inverting terminal of the op amp minus. This is very important. Okay. Now because you apply input at the inverting terminal, the output whatever you get here, will be out of phase with respect to input. Okay. Now the output here will be a amplified version of the input. So it will be 180-degree out of phase. It will be in this way. Okay. Now your input was like this. So output, you can see this is the output, is the amplified version, but in an inverted way. There is a phase difference of 180-degree. Okay. Now here, how much amplification you want to do at the output depends on the gain of the circuit. And the gain depends on the feedback resistor R2. So here we are shown R2 as the feedback resistor and the input resistor R1. Okay. R2 and R1 will decide the gain of the circuit. Okay. So minus R2 upon R1 will be the gain of the circuit. And that many times, whatever you choose R2 and R1, R2 upon R1, what you get will be the gain. And that many times the output will be amplified with respect to input. And the output will be an inverted version of the input. The output will be 180-degree out of phase with the input. Okay. So it is called as an inverting amplifier. And here feedback we are going to give to the negative terminal. So it is a negative feedback. Okay. And the input also we are going to give to the inverting a terminal. So it is an inverting amplifier. Okay. Then from this circuit, it is clear that the feedback provided to the op amp so as to have the closed loop operation of the circuit. To have the accurate operation of the circuit, negative feedback is provided to it. Thus, to have a closed loop circuit, the input as well as the feedback signal from the output is provided at the inverting terminal of the op amp. So from the above given network, the gain is given as gain is equal to AV is equal to R2 upon R1 minus R2 upon R1. Okay, so here you can see the gain of the op amp circuit. So that is the inverting amplifier circuit. So minus R2 upon R1 is the gain, means whatever value you choose for R2 and whatever value you choose for R1. Say for example, if I want the gain to be 10, then it R2 have to choose as 10 times more than R1. Say for example, if R2 is equal to 10 kilo ohms and R1 is equal to 1 kilo ohm, then the gain will be equal to 10. Okay. In that way, you can choose the gain, you can adjust the gain, you can decide the gain in a closed loop circuit. And this gain was for your inverting amplifier. And minus R2 by R1, because minus sign will come because you are having a 180-degree phase shift at the output. Okay. So here, this is what is the concept of inverting amplifier. Clear? Now we'll go next to see what is non-inverting amplifier. So a definition of non-inverting amplifier says that an amplifier that produces an amplified signal at the output having a similar phase as that of the applied input is known as the non-inverting amplifier. This simply means that for an input signal with a positive phase, the output will also be positive. Also, the same goes for input with the negative phase. Okay, that means if you see the circuit here, the input is applied to the non-inverting terminal. So if you see here, this is the input applied here. Input is applied. So this is with respect to ground. This is ground. So here you are going to apply the input. So this is the input, say applied, and it is applied to the non-inverting input, that is plus of the op amp. Okay, and feedback is negative. Feedback you are taking with a resistor R2. Okay, so this is your feedback resistor R2 and this R1. Okay, so these both will decide what should be the feedback, what should be the gain of the non-inverting amplifier circuit. Okay, and here you will get the output. Okay, so depending upon the gain, the output will be a amplified version of the input, and it will be in the same phase. There is no phase difference. It will be in same phase because input you are applying to the positive terminal, not to the negative terminal. So input you are applying to the non-inverting terminal here. Okay, so output will be an amplified version of the input. So this will be our output. It will be an amplified version of this input. And you can see it is amplified with the gain, and the gain will be decided by R2 and R1 resistors used in your negative feedback configuration. Okay. So here if you see, in this case, to have an output of the same phase as input, the input signal is applied at the non-inverting terminal of the amplifier. But here also negative feedback is to be provided. Thus, the feedback signal is provided to the inverting terminal of the op amp. That is why it is called as negative feedback. The closed loop gain of the non-inverting amplifier is given as, this is important here. Now, in non-inverting amplifier, the gain is given as 1 plus R2 upon R1. So here you can see this is 1 plus. So the gain is equal to 1 plus R2 upon R1. Okay. So if you take R2 as 10 kilo ohms, if you take R2 as 10 kilo ohms and R1 as 1 kilo ohm, okay. So this will be around 11. Okay. So this 11 will be the gain. That means the output will be 11 times more than the input. So in this way, by choosing R2 and R1 with the appropriate value, you can decide the gain of the circuit. And the gain of this amplifier will tell you how much amplification you will do for the input signal at the output. Okay. So a conclusion, if you see about both the circuits, the above discussion about inverting and non-inverting amplifier concludes that in both inverting and non-inverting amplifiers, negative feedback is used that helps to provide the controllable gain. Okay, it is a controllable gain. That means you are observing, you're managing stability of the circuit also. That helps to provide the controllable gain of the amplifier. Okay, so this is the conclusion of the both circuits. So in inverting amplifier, you are going to get an amplified of 180-degree phase shifted output, and in non-inverting amplifier, you are going to get without any phase shift the amplified version of the input. Okay, so this was your discussion of inverting and non-inverting. Now again, if you go to see the second concept of inverting amplifier, so here you can see when we did this inverting, okay, actually this op amp was going to give us the difference between the two voltages. So here you can see the op amp will amplify the difference between the two voltages, VID. Okay. Now here one voltage is given as it is. This is V in. So V in is your one voltage, and the other voltage is ground. So the difference will be V in only. Difference will be V in only, and that V in, because you are applying to the inverting terminal, okay, it is inverted at the output. Same case if you see with the circuit of non-inverting terminal, even here the output will be the difference between the two inputs. So here you can see the difference between the two inputs. Now here one input is your V in, okay, as it is, and the other input is connected to ground. Other input is connected to ground, so it is as good as you are applying this input only. Okay, so that input, when you are applying to the non-inverting terminal, it will come at the output with a without a phase shift. Okay, so the phase shift is 0, and as it is with the same phase, it will be amplified at the output depending on the gain, which will be decided by R2 and R1 resistances. Clear? So this was your explanation about the circuits of inverting and non-inverting amplifier using operational amplifier op amp. Okay. Thank you, students.